Let's talk about ThreeJS. ThreeJS is a 3D library for JavaScript, which basically allows you to add 3D to your website. You can make portfolios, you can make games, you can make some experiences for your user, stunning just like you. So I will teach you how to put your stunningness into your website using ThreeJS. First, what the hell is going on? Because this usual HTML stuff does not look anything like this. Well, we have a thing in our browsers called WebGL. WebGL is able to translate your JavaScript into machine-level code that your GPU can understand. The GPU will then use your instructions to render on screen whatever you just wrote. So WebGL actually takes care of rendering stuff on screen, and ThreeJS is just a JavaScript library which tries to make rendering with WebGL as easy as possible in your application. In order to understand what's going on, I will give you some definitions before we write some code. So everything in ThreeJS is wrapped inside what we call a scene. You can think of a scene as a container which mainly has meshes and lights. Generally speaking, when you see some piece of work with ThreeJS, you're looking at a scene. So this, and this, they're all scenes. Any 3D object you see in a scene is a mesh. A mesh is nothing until you give it a geometry, however, which has information about its vertices, edges, and faces. So your mesh has a shape thanks to its geometry. If you saw the animation, you would be like, well, I just take a mesh, I give it a geometry, and I can see it on screen. But that's actually wrong. See, a geometry only tells your GPU how to position its vertices in space. Now, how you see the mesh is something that you get from the material. In ThreeJS, a material is a JavaScript object which has information about texture, color, how it should react to light. So you take a mesh, you give it a geometry, you give it also a material, and you can finally see it on screen. Ha, you wish! We actually need a couple more things before we do that. And those final things would be a camera and a renderer. So a camera is exactly that. It's a place from which you, the user, are meant to observe the scene. And the renderer, instead, is pretty important because it takes the scene and the camera and generates an image to your browser, which represents the finished scene. Whew. We're gonna now write a quick coding example using Vite, Three, and TypeScript. So begin by pasting these commands in your terminal. Cool, so step 1, delete everything from main.ts and change that div with the app ID to a canvas. Just put a custom ID, make sure to remember it. Go to tsconfig.json and change the module resolution to node. This is gonna save us some pain later on. We're gonna define the core of our logic in a main function inside main.ts. Grab the canvas, make sure it's not null, and create a scene and a camera. The camera is gonna need a FOV as a parameter. Generally, any number between 50 and 70 will do for a standard FOV. We're also going to add our renderer, which is going to talk to the GPU and render the scene. Some settings are required. For example, alpha makes it transparent, anti-alias makes it look nicer, and canvas is a reference to our canvas element. We're going to now place the camera a little farther away from the scene and make it look at the origin. The scene is going to need a mesh to render something, and we're going to go for a sphere. To do that, we're going to create a geometry and a material and bind it to a mesh. Finally, add it to the scene. Do the same thing for the floor and rotate it so that it appears on the right side. Since I'm a man of strong decisions, I'm going to switch the colors and add some lights, just like this. So I'm going to add some boilerplate code. We're not going to get too much into this, but basically, whenever the user changes the viewport, we want to update the camera aspect and the renderer size. To allow the user to rotate the camera with their mouse, we're going to use orbit controls. Just make sure to add this funny import line at the beginning. To make the sphere bounce, we're going to set its position to a normalized version of math.sign, basically interpolating it between two y's that we defined. We're going to recursively call this with a request animation frame so that this will not be a still image. Finally, we're going to change the background color and make the canvas occupy the whole page. And lastly, import the style inside main.ts. Thank you for making it this far, and I'll see you in the next video.